Let's move on to the next question. So the question is, what is the difference between volatile and atomic integer? This is one of the, I would say, interesting and tough thread questions for many actually. Even though you guys have read about it, but still I have seen 90% of the candidates will fail to answer the difference between volatile and integer correctly. So let's see with some examples and understand the differences. So before I go and explain about volatile example, right, I'll just give you a theory. So I'll first explain it orally. So volatile is used to solve the visibility problem. Let's say there is a boolean flag is there, and initially maybe it is true, and the first thread, right, has changed the value of flag to false. There is another thread called T2. So what value T2 will see? T2 will get basically true itself. So for T2, flag values true itself. So mainly because flag value true is in the memory. Okay, this is in the memory. So whenever a thread makes changes, like here, even set the flag to false. But this will not immediately reflect in T2 because this T1 store this false in its cache. So this T1 store this value in the thread cache initially. Later it will flush this value to the memory. But by the time thread 2 have already got the value of the flag as true, but actual value is false. So this is the problem statement. So one way you can do is you can go with synchronization and you can lock the entire block of the code and you can make it thread safe. Other way is you can use volatile. So if I make this volatile, okay, if I make this variable as volatile, what will happen? Whenever a thread make any changes to this value, so let's say if it is set as false, right? So this will not be stored in the cache, it will directly go to the memory as false. So this will be in the memory. So another thread, when it tries to read the value of flag, right, it will get false as the value. So basically what volatile does is whenever a thread makes changes to a variable, its value will be stored in the memory directly instead of cache so that other threads will get the correct value. So that's the main use case. Let's see with an example. Okay, so here in this, right, I have created a volatile boolean flag as false here, and the first thread is called a setter thread. So here I have introduced a sleep of 1000 milliseconds, and I'm setting the flag as true, and I'm even printing that flag is set to true by the setter thread. Okay, so here waiter thread, what will it will be keep on waiting for the flag. So if the flag value becomes true here, right, it will come out of this while loop and print this. So current value of the flag is false. So basically this will go on in an infinite loop. So when the first thread makes the value to true because of the volatile nature, this value will reflect in the second thread also because it will read from the memory, and it will end this infinite loop and it will print the statement saying whether the detected flag is true. So here we are starting both the threads, wait a thread and set a thread. I'll just run this example and show you. So here you can see it was keep on printing false for some time. False means it was inside this while loop. So this waiter was inside the while loop. But at one point, when the flag was set to true by setter thread, immediately waiter thread detected it and exited. So I hope you got it. So here, because of the volatile thing, right? As soon as the first thread updates the value, second thread picked up that value because it was visible to second thread. So volatile is used to solve the visibility problem. So whenever a thread makes any changes to variable, its value will be returned to the main memory so that other threads will get the recent appropriate values. But let's say I'll give you another example. Here I have created another class. So here I have a class called volatile counter. Okay. So I have a count variable. I'm just running this with 1,000 times. So basically this is a thread. Okay. Volatile counter is a thread which is implementing the runnable. What I'm doing is I'm creating two threads on that, T1 and T2. For both of that, I'm passing this counter. Okay. And I'm starting the thread and I'm joining and I'm printing the final count of it. So each of the thread will go and run this 10,000 times and print the result. So I'll just run this and show you the result. You can see we got 15,323. See here we got 15,323. I'm running it again. So we got some other value. So every time when I run, I'll get some different value. What it means is this is not thread safe. Okay. So if I have to make it thread safe, right? So let's say if I change this to volatile. So what happens in case of volatile? Whenever a thread makes changes to value, it will be immediately reflects in the another thread. That's the actual behavior. So when I run this, so here you can see we got some 18,000 change. When I run it again, I got something else. When I run it again, I got something else. Means volatile is also not solving this problem. Still, this code is not thread safe. It is printing unexpected values only. And how to make this thread safe? One way is we have to synchronize this execution and we can make it thread safe. But let's say interviewer asks you, can we do without using synchronization? So yes, you can do. What you can do is instead of this volatile, you can go for something called atomic integer. So here I'll just create an atomic integer with value 0. And here instead of count plus plus, you use something called increment and get. That's it. So I'll just run this code and show you the result. It is printed 20,000. So I'll just print one more time. Again 20,000. Third time I'm running 20,000. So basically it is consistently resulting 20,000. What does it mean? So this atomic integer is making this code thread safe. Let's try to understand how it is working. So basically, whatever the increment operation I had initially, right, like count plus plus, maybe count minus minus, these are not atomic in nature. Means it's not one operation. Like in case of first example, right, updating a flag, it's just one operation. You are just assigning it, writing it. But in case of this counter, what will happen is when you do count plus plus, there are three operations happen. One is read the count, and second is update the count, and third operation is basically write the count. So it's basically write the count back to the memory. So I'll just comment it and explain. So here first read is happening. After that we are updating, means count plus 1 is happening. This we are writing back to the memory. So three operations we are performing. So this is not atomic in nature. So what this atomic integer does, it will make count plus plus as atomic. That's why we are calling a count increment and get. We are not calling count plus plus. We are using atomic integer. It has its own function called increment and get. Internally, it uses a concept called compare and swap. So that's how it will make this code thread safe. I hope you got it. So this is one of the classic and interesting interview question. When to use volatile, when to use atomic integer. Many of the candidates will struggle and give wrong answer. Atomic integer, right? It has its own performance issues. So in the latest versions of the Java, after Java 8 onwards, so they introduced different so Java introduced better versions. It's called as long adder, long accumulator. So these are all better in terms of performance as well as thread safe. for non-atomic operations. So it will convert it into atomic and make it thread safe, and it will work faster compared to atomic integer. So this is what the bonus point. So whenever you are learning anything, right, see what is there any latest changes are introduced. Don't just stick on to whatever is available in 100 other tutorials. Explore what is available in the latest versions of programming language or framework so that you can keep yourself up to date. I hope it's very clear to you. Explore long adder, long accumulator after this tutorial. Understand how it works, how it is better than atomic integer, what techniques it uses internally to make it more performant. Go and check it out. I hope this is very clear. So let's move on to the next question. The answer is very clear. Volatile is basically to handle the visibility problem. So it does not work for operations like x plus plus, x minus minus, increment, decrement, etc. It's only suitable for one-time update like flags, status update, etc. Atomic integer, it basically is compare and swap, make the operation atomic, and it will make thread safe. Let's move on to the next question.